In this video, we are going to discuss about experiment number 4. Here, our aim is to design counters and shift registers, state machines, parallel adders and multipliers based on HDL, and we have to simulate the design and verify its functionality. So for that, first of all, we have to open Xilinx. Here in the left side start window, we have to choose new project. Here how to browse, and we can provide the path for our project. Okay, I am going to give the name as exercise number 4. Click next, and we have to check the specification of our device. For example, the family of the FPGA I have chosen here is pattern 3E, and the device has X3S35500E, and package is FT256 and speed -4. And once we finished creating the project, we will check the project summary and click finish. And now our new project is created. You can check that in the hierarchy window here. And this is our device, and after creating the project we have to click the device and right click and give new source. Here we are going to design a Verilog module, so that first of all I am going to design a counter. So I am giving the name as counter 1, and this is the portion to define the module. And if you wish, we can give the name of the ports here itself. I am going to give the name in the module in the code. And here comes the summary window, and click finish. And now our counter v file is created and it's empty, and I am going to paste the coding. How to save this particular v file, and we have to check the syntax. For that, in the process window, within the synthesis, we have to click check synthesis and run. Now we can see there is a green tick mark which indicates there is no error in our code. And after this, we have to create a test bench file in order to check the simulation. So again, I'm going to right click on the device, and I'm going to add now the Verilog text picture. So I'm going to provide the name as test underscore counter, and click next. And by default, the test bench for this particular v file for counter will be created, and we can edit this particular test bench for our own values, expected values. So I'm going to replace this particular test bench also. We can replace this particular, and we can save this particular file. And now we have to test whether this particular test bench is correct or not. For that we have to save this particular file and click simulation and highlight this particular file, and here you have to give behavioral check syntax and choose simulate behavior module. Our coding is running, and you can check in the console window that it is successfully completed. And now we can check, see here you can check whenever a clock pulse is 1 and the up count will be happening, and after that down count. This is the output waveform. So in this way we can manually feed the test bench code and verify the functionality of our module. Or else if we are using the default test bench, we have to provide the inputs, and we can see that one now. Now I'm going to do the same operation for our adder. For that I'm going to simply retain this particular project, and simply I'm going to add the source file alone. For that, ensure that this particular design is in implementation, and then right click this new source. Here choose Verilog module and give adder underscore 1, click next, click finish, and then the window opens, and here we can give the values and save this particular file, and then have to choose the option called check syntax in order to check the syntax of our code. And now once the green tick is enabled, we can go for adding test bench. Click again the device and choose new source and choose Verilog text picture, adder underscore 1 underscore test. Now our test bench is created, and this is the generated test bench file, and I'm not going to modify this particular test bench file this time, and I'm going to run that particular generated test bench file, and I'm simulating that one. Now our simulation window is opening, and here we have to manually feed the inputs, and then we can save this particular waveform and run to see the output. Actually, in the previous case of counter, we have manually feeded the test bench code which carries various set of input conditions, so that we got the output once we run the particular coding. But this time I'm going to use the generated test bench file, and here I'm going to feed the inputs manually. See, you can right click this one and you can change the radix. I'm going to keep it as an unsigned decimal, so it will be easy for us to verify the output. And now I'm going to give the value. For that, choose force constant and give the value as 15. I'm going to give as 15. Choose apply and then click OK. Next, I'm going to give another value as 20. Click apply and click OK. And we have to ensure that we have provided all the inputs properly. For that, go to our module and check what are the inputs. Only only three set of inputs are there, A, B and C in. And here S is an output and C out is an output. So no need to provide an input. See, now we can run this particular file. Before that, save it as in the name of adder. Then you have to click run button. It's a compact and zoom view. Okay, here comes our output. And I'm going to change the radix of my output also. See, I have provided the input as 15 and 20. Here comes 35. And again, once again, I'm going to change my both the inputs. This is initial state and this is the final one where we have got our output. Okay. Now I'm going to provide another set of outputs, input. Apply. Okay. Apply. Okay. Save this particular one and run it again. See, now you can clearly see two sets of outputs. See, in this case, here 40, 25, 15. This is the second set of input I have given and our answer is 40. And this is the manual way of feeding inputs and getting simulated output. Thus, our module, that is, we have designed using HDL. Here, this adder particular module is working properly. We have verified this particular functionality by using this simulation. The similar way, I'm going to do the same operation for our shifters also. Here you can check the answers for universal shift registers, for multiplier and state machines. The similar manner we can do for all other coding HDL also. HDL based coding for our shifters and others.